Hello everyone, welcome to my math class. In this video, we are going to look at the third group of differentiation and integration formulas, which is about exponential and logarithmic functions. Let's get started. When we differentiate the exponential function e to the power x, the result is e to the power x as well. So this formula, we can link it to the roly-poly toy. It means when we differentiate the exponential function, the result will always be itself. For the integration formula, since it is the inverse operation of differentiation, then when we integrate e to the power x with respect to x, the result will be e to the power x. Now we add c for the indefinite integral. For these two formulas, we can also change x to the general linear function ax plus b. Then, in this case, the inner function is the linear function x plus b, and outer function is the exponential function. And then by using the chain rule, we will have e to the power ax plus b. And for the inner function ax plus b, the derivative is a. We are going to multiply the result by a. Can put it to the front. For the integration, by changing x to the generalized form of ax plus b, the result will be e to the power ax plus b. For differentiation, we multiplied a to the result. Consider the opposite operation. We are going to divide the result by a. Therefore, we will have e to the power ax plus b, then divide by a. We add c for the indefinite integral. Now we are going to apply these formulas to find the following definite integrals. First one, we have e to the power 2x minus e to the power x, integrate from 0 to 1. The first function is the compound function. The inner function is 2x and the outer function is the exponential function. Therefore, we are going to use the generalized form of the formula to get e to the power 2x and then divide by the coefficient of x, which is 2. For the second function, e to the power x, this one is a basic exponential function. The formula is the first one, and then e to the power x. When we put 1 in, we will have e to the power 2 divided by 2 minus e to the power 1. Then minus the result of substituting 0 into the expression. Then e to the power 2 times 0 is just 0 over 2 minus e to the power 0. Simplify to get the final answer. E to the power 0 is always equal to 1. Then when we expand the brackets, the negative sign changes the sign of every term in the brackets. Therefore, we will have positive 1 here. By collecting like terms, we will have the final answer. E to the power 2 over 2 minus e plus half. Now let's move on to part B. It's very similar, and the key step is to distinguish whether the function is the basic exponential function or we are going to use a generalized form. In part B, e to the power x, this one is the basic function. We are going to apply the first formula. And then for the second one, it is the generalized form. Because inner function is negative x, it means the coefficient of x is negative 1. And then outer function is the exponential function. Then for this, we are going to use the second formula. The result will be like this: e to the power x, then minus, for the second one, e to the power negative x as well. And don't forget to divide the whole thing by the coefficient of x, which is negative 1. After that, we record the lower limit and upper limit. Then we are going to simplify the expression first. Here we have negative and negative 1. It will become positive e to the power negative x. Then record the lower limit and upper limit. After that, we substitute the value. When we substitute number 1, we will have e to the power 1 plus e to the power negative 1. Then minus the result when we substitute e to the power negative 1. We will have e to the power negative 1 plus e to the power negative 1 will become positive. Therefore, we will have e to the power 1. Then we will expand the brackets. E to the power 1 just e, and e to the power negative 1. We can keep this one, and then for the second bracket, it has the negative sign in front of it. Therefore, we will have e to the power negative 1, and then negative positive together for second term, we will have e to the power 1, it's just e. We can see e to the power negative 1 minus e to the power negative 1, they cancelled out. The result is 0. And similarly for e minus e. Therefore, the final result is 0. Then let's look at part C. Here we have e to the power 3x and x. For the first part, e to the power 3x, it is the generalized form. The coefficient of x is 3, it means a is equal to 3. And the second part, x, we will need the power rule. Now we are going to record here for x to the power n dx. The result is x to the power n plus 1 over the new power, then plus c. The restriction is n is not equal to negative 1. X, it means the index is 1. E to the power 3x first, and then we are going to divide the result by the coefficient of x, which is 3. Then for the second part, x to the power 1, then the new power will be 1 plus 1, which is equal to 2. Then we are going to record it to here and divide by the new index. Record the lower limit and upper limit. E to the power 3 divided by 3, then plus 1 squared, just 1. Then we will have half. Then we substitute the lower limit 0. E to the power 3 times 0, it's just 0 over 3. Then x squared, then we will have 0, because 0 squared is 0. E to the power 0 is number 1. Last two terms are like terms. We are going to simplify to get the final result. By looking back at these questions, we can see the key step is to identify the functions and use the corresponding formulas to integrate.